In this video, we're going to talk about free body force diagrams, or free body diagrams as they're sometimes called. And there are three pretty simple rules that go with this. And this is a relatively easy topic to understand, but the reason we want to spend some time with it is to make sure we do it correctly, because it'll make things easier on us later on down the road. Our first rule is to draw a very simple picture of the object. And that might seem like something that's obvious and maybe is not rule worthy. However, a lot of times what I will see on homework and on tests is people spend so much time drawing their pictures and having fun with it that they don't have enough time to do the problems. There's nothing wrong with having fun with drawing a picture, but if you're drawing a ship, we don't need to draw a full pirate ship and cannons and people attacking other ships. Just simply draw a simple boat diagram. The second thing is you're going to place a dot at the center of mass of this object. Now, the center of mass is something that we may have talked about at this point. Maybe you're not understanding it. If you're not really sure, put it at the center of the object, because many times that's where the center of mass occurs. But the center of mass is something that represents the total mass at a certain point, and we can represent that with a vector. So if you're not sure, put it at the center of the object. If you're understanding center of mass, go ahead and put that down. For sure, we'll understand that with some other video if we need to. And then the final thing is use arrows to indicate the size and direction of the forces, and always draw them away from the dot. And that's also important because it helps us understand how forces are affecting this object. And to further illustrate that, what we're going to do is do some simple examples. So our first example is just simply a book on a table. So I'm going to select a pencil here, oops, not letter, pencil, and just simply say, okay, we're going to draw a book on a table. Well, here's our tabletop, table legs, here's our book. Now, again, I drew a very simple picture. In this case, it's kind of a box. I place a dot at the center of this, centering basically the sides and the top. And then I have to think a little bit here, because I'm not given any forces. What are the forces that affect a book? Well, we know for sure, or if when I ask these questions, I always get this one, that gravity. Is pulling this book down, and that's true. And then hopefully remember from Newton's second law, if we have a force, that it has to make this move. And if we remember Newton's third law, we know that there's got to be an equal and opposite force that's also here. And this would be the force pushing it upward from the table. And what that kind of helps us understand is there's a book sitting on this table here, and it's not going to move because this force and this force are the exact same amount. Okay? Another example, a car speeding up. So again, just a simple picture of a car. My car pictures are always brutal. So there's no reason we have to have anything very fancy here. Okay, and the car is speeding up. We'll say that it's moving in that direction. I'll just give it a little velocity arrow here. So again, what are the forces affecting this? Well, again, just like the book in the last example, we will have the force of gravity, which I'm just going to call Fg. We know that that will be balanced out with the force of the road. Now, those again are equal because our car is not jumping up and down. Now, this car is accelerating, it's moving forward, so we know we're going to have a bigger force going to our right than there is one going to the left. And that would probably be the force of the engine. And the force that's going back could be a couple different things. It could be air resistance, it can be friction. Typically, we can just call these frictional forces. But what we want to notice is the force going forward from the engine is more than the frictional forces going backwards. And if we would figure out the net force on this, it would be basically going in that direction, which tells us that this car will then accelerate. It's got more force pushing it forward than what it does pulling it backwards, so it then is able to go in a forward direction and speed up. The next one is the car slowing down. So again, I'm going to attempt to draw a car, and maybe I'll draw one slightly different this time, but probably just as brutal as what it was last time. And again, we have a velocity of this car moving this way. Same idea. We know there's going to be gravity pulling it down, and then counterbalanced by the force of the road pushing that back up. If you don't have the road force, again, this car should move downward. We said that the velocity of this one is going to the right. So we have to think about this. This car is slowing down, which means we probably are pushing on the brakes. and not pushing on our accelerator. So there might only be a force going back from the brakes. So the force of the brakes, plus we probably still have our frictional forces like air resistance and rolling friction. So we know now that this car, even though it's moving forward, the net force is pushing it backwards. So the reason we want you to draw this from a center point is so you can recognize that all these forces are kind of going to cancel each other out. This force and this force, the up force and the down force, don't affect the motion of this because they're canceling out. Our last one is a hot air balloon ascending and moving to the west. So again, hot air balloon, just a simple picture here. Doesn't have to be anything too crazy. Like that at all. Let me try that again once. Maybe you want to put a basket on there for the people to sit in. But whatever, there's our hot air balloon. I'm just going to change colors to make it a little easier. Again, a dot at the center of mass might be here. It doesn't have to be perfect on the center of mass. Is gravity affecting this? Absolutely. You got the force of gravity. Now, a couple different things are happening. This is moving to the west. So you know it's probably something like the wind blowing this. Because hot air balloons really can go up and down as far as what you can control. But the way they move is determined by the wind. So there's probably a force there. And it's also ascending. So we need to have some other force that's acting on this, and that might be the buoyant force, or the lifting force, we'll call it. Now, if this force here isn't greater than this force, it's not going to go up. If they're equal, it's like our car. It's just going to sit there. So again, when we think about our net force for this, there's two directions we have to account for. It's going to be some going up and some going to the left or to the west, which should give us an overall force of that, if you remember our vector addition from before. So those are just 3 or 4 relatively simple diagrams for drawing free body diagrams.